Hello everyone. I am Cubity.
I am Verbis.
From the past to the present within the scope of our atomy twinning project. Now I will give you information about atomic models developed from past to present. First view of the atom. Greek philosopher in 400 BC. It was introduced by Democritus. Democritus argued that matter is made up of particles, and this. He named the particles atoms. Democritus, atom based on assumptions, not experiments, said accordingly. Atom, according to Democritus.
When matter is divided into parts, it is ultimately indivisible. A particle is obtained and this particle is an atom. All matter consists of the same type of atoms. The reason why the substances are different. The number and arrangement of atoms are different. Atom cannot be seen. Atom cannot be divided because it cannot be seen.
The term atom was reintroduced after Democritus. John Dalton was the first scientist to bring it. Dalton, all matter is small, revived the idea that it was composed of particles and suggested that all atoms of an element are the same. It took Dalton, filled with atoms, Burke and indivisible. He thought they were spheres. Therefore, Dalton atom in atomic model, billiard ball is likened. According to Dalton,
elements are made up of extremely small, indivisible particles called atoms. All atoms of a given element are identical. That is, these atoms are equal in size, all have the same mass, and their chemical properties are the same. However, the atoms of one element are different from the atoms of all other elements.
After Dalton, scientists' models that try to explain its internal structure have evolved. The first of these is the British B. Joseph John Thomson developed. Thomson thought of the atom as negatively charged particles in a positively charged sphere. This model can be described as the raisin cake model. The pulp of the raisin cake is positively charged particles, while the grapes are negatively charged particles. According to Thomson,
atom is composed of positively charged matter. Electrons are embedded in this plus matter and do not move. Electrons have very small masses, so positively charged matter makes up the entire mass of the atom. Atom is spherical. Thomson, why and how can the positive charge continuously fill the remaining volume of the atom, even though the negatively charged electrons are in the form of particles? Did not explain the question.
New Zealand-born physicist Ernest Rutherford to the atomic model. Positively charged particles in the center of the atom was in the nucleus and electrons was spinning around fast. The Rutherford model of the atom is likened to the solar system. Most of the rays sent through the sun passed directly through the plate. A proton-filled nucleus and electrons revolving around it are likened to planets. According to Rutherford,
there are large voids in the atom. The positive charges in the atom are collected in a small volume called the nucleus. Most of the atomic mass is concentrated in the nucleus. There are as many electrons as positively charged particles in the atom, around the nucleus, and electrons occupy most of the atom's volume. Electrons orbit around the nucleus. Incompleteness and errors of the Rutherford atomic model. It couldn't find the neutron. He could not fully explain the locations and motions of electrons.
The model put forward by the Danish scientist Niels Bohr. It can be compared to the Rutherford model. Bohr's atomic model earlier atom. The most important feature that distinguishes it from the electrons scattered throughout the atom not available, but in certain layers indicates that it can be found. This model constitutes the model of the modern atomic model currently accepted. According to Bohr,
electrons in an atom move in orbits at a certain distance from the nucleus, and their angular momentum in these orbitals is h over 2 pi. Every steady state has a constant energy. At any stable energy level, the electron moves in a circular orbit. These orbitals are called energy levels or shells. While the electron is in one of the stable states, the atom does not emit light, radiation. However, when it moves from a higher energy level to a lower energy level, it emits a quanta of light equal to the energy difference between the levels. Stable levels at which electron movement is possible are designated by letters such as K, L, M, N, O, or each energy level is designated by a positive integer, with the lowest energy level being 1 and generally denoted by N. Shortcomings of the Bohr atomic model. Since electrons are so fast, they had to be considered not only in classical physics, but also in relativity. The Bohr model of the atom, it can only explain the spectra of single electron atoms, hydrogen. It cannot explain the spectra of multi-electron atoms. Wave-particle duality, the Broglie hypothesis, is not considered in the Bohr atomic model. According to the Heisenberg uncertainty principle, the location and velocity of the electron in the atom cannot be determined simultaneously with absolute precision. Therefore, the concept of orbit is wrong. There are no neutrons. Neutrons were discovered by James Chadwick in 1932.
The modern atomic model, created after the Bohr model of the atom, is a theorem that reflects today's views on the atom. In this theorem, it is assumed that the velocity and position of electrons cannot be found at the same time, and that electrons have certain orbital movements. The modern atomic model, which is very close to the Bohr atomic model, consists of the accumulation of scientists who worked before it. Atomic model is accepted as the common view of not only one person, but also scientists who do all studies about the atom.
The assumptions of the modern atomic theory model are: electrons exist in certain energy levels around the nucleus. Each energy level is denoted by n.
These energy levels are called principal quantum numbers. The principal quantum number determines the average distance, or energy, of the orbitals from the nucleus.
Energy increases as you move away from the nucleus. Because the attraction power of the electrons of the protons decreases, accordingly the movement and energy of the electrons increases.
Electrons revolve both around themselves and around the nucleus.
The rotational motion of the electron around its own axis is called spin motion, and the rotational motion around the nucleus is called orbital motion.
Geometric regions around the nucleus, where electrons are most likely to be found during their rotation, are called orbitals.
There are n-squared orbitals at any fundamental energy level. In each fundamental energy level, there can be 2 times the number of orbitals of electrons.
What we will tell about atomic models ends here. Thanks for listening.
Thanks for listening.